Hello everybody, my name is Saif Khan. I'm the head of NUS Chemical and Biomolecular Engineering, and today I'll share with you some of the excitement of the discipline of chemical engineering. Chemical engineers meet societal needs. We take a handful of raw materials that nature gives us and transform them using a variety of processes into thousands of value-added molecules that end up becoming the products that we use in our daily lives. In fact, if you just look around yourselves, nearly every product that we use in our daily lives, everything from drugs to fuels to vaccines to food products to even semiconductor chips, are products of chemical engineering processes. At the same time, while meeting societal needs, chemical engineers are playing a vital role in meeting the interconnected crises that we find ourselves in across the globe. So we are tackling global challenges at scale, challenges related to climate change mitigation, the availability of clean energy, the availability of drinkable water, and also healthcare for all. So let me just, in the next few minutes, lead you through some of the exciting things that chemical engineers are contributing to today in addressing these global challenges. So let's take the example of climate change. One of the biggest solutions to climate change is the idea of carbon capture, essentially mitigating the release of carbon dioxide into the atmosphere. Now, if you look around yourselves, every major solution which is of global scale and that is proposed for carbon capture is in its very essence a chemical engineering solution. Whether we are talking about direct air capture of carbon dioxide from the atmosphere or interesting technologies like chemical looping or adsorption or membrane-based capture. In fact, chemical engineers have a long history of making global scale contributions. So for example, one of the most important processes from the field of chemical engineering is the process to convert nitrogen from the air into ammonia for fertilizers, the famous Haber-Bosch process. Did you know that nearly 50% of the nitrogen in our bodies is a Haber-Bosch nitrogen? That's the scale of impact that chemical engineers have made and continue to make at the global scale. Now, chemical engineers at the same time are also leading the charge towards greener sources of energy, towards a transition towards fuels that are made even from waste materials. So chemical engineers and chemical engineering processes are playing the core role in thinking about this energy transition, and we are taking steps towards this energy transition even in Singapore today. At the same time, the availability of clean drinkable water is a big problem worldwide. We're surrounded by oceans, and yet most of that water is undrinkable. Why is that so? It's because nature has mixed salt with that water, and separating the salt from the water is a really challenging problem, and it turns out it's a chemical engineering problem. Therefore, processes like reverse osmosis that are routinely now employed to desalinate salty water are chemical engineering processes in nature. So we at NUS Chemical Engineering are playing a vital role both at the national and at the global level in really thinking about innovations at this confluence of being able to provide clean drinkable water, but at the same time being able to clean up municipal sources of water. And professors at NUS Chemical Engineering work routinely with entities such as the Public Utilities Board in Singapore on these kinds of problems. And last but not least, we've all been through a pandemic. Now, did you know that Moderna, one of the major vaccine suppliers for the COVID-19 pandemic, was co-founded by a chemical engineer, one of the most famous chemical engineers in the world, Professor Robert Langer. And what that highlights is that the translation of the discovery at the biology level of RNA-based therapeutics, taking that discovery and bringing it into the form of a vaccine that then can be taken by millions of people worldwide, is a place where biology meets chemical engineering. So modern RNA therapeutics and indeed therapeutics of this kind of are fundamentally involve chemical engineering processes. So it's a really exciting time to be a chemical engineer. So having said that, what do you learn in chemical engineering? Well, we learn one key what question in chemical engineering. What are the key physical, chemical, mathematical, and engineering principles that enable you to design clean, energy efficient, sustainable, and economical processes for chemical or biological transformation of naturally occurring raw materials? Now, once you have some idea about this what question, it's almost like a superpower because it allows you to address so many how questions. How do you capture carbon dioxide to minimize environmental damage? How do you provide really drinkable water at cheap rates to a lot of people? How do you create new drugs, new vaccines? How do you minimize gas emissions from vehicles? How do you create better, smaller, faster computer chips? That's a problem in chemical engineering. And even these science fiction sounding scenarios like making living on Mars a feasible proposition involve very important problems in chemical engineering. At NUS Chemical Engineering, we try to give you a really vivid map of the discipline, all the foundational ideas right from year one. So right from year one, you're engaged in studio-based instruction where you work with groups of students, not just in doing experiments for the sake of doing experiments, but really trying to bring the foundational concepts alive. And indeed, we also, through these studios, engage you with the idea of biology meeting chemical engineering. So indeed, using biological cells as chemical and pharmaceutical factories is an idea we engage with at the year one level in studio-based instruction, where, for example, you work on processes such as fermentation of all kinds of fruits. Now, the curriculum at NUS is really amazing in that it gives you so many options to craft your degree. You have a chemical engineering core, and then there is a list of very exciting specializations, minors, second majors, that you can then combine to allow you to diversify your options towards a number of different careers. Whether you want to specialize in a career in biopharma, or become a process engineer, or become even a commodity trader, there is something in the curriculum that you can fit together to suit your ambitions. At the same time, student life at NUS Chemical Engineering is exciting and extremely vibrant. We have a very strong student ecosystem. We have a lot of industry talks, alumni lectures, and our peer support system is absolutely exceptional. At the same time, so when you're inducted into NUS Chemical Engineering, you basically become part of this family where you can also leverage a lot of networking opportunities with industry practitioners as well as alumni and both, for example. We also have a lot of opportunities for overseas training. Most of our students go for student exchange programs and even participate in all sorts of interesting symposia like leadership symposia, business symposia, etc. In terms of careers, the sheer number of places where chemical engineering impacts your daily life means that with this one discipline, it opens up access to a number of industry sectors. Everything from chemicals to foods to energy to pharmaceuticals to semiconductors, even areas such as finance can be tackled by a training in chemical and biomolecular engineering. And given that, we have a number of alumni that have become very successful in so many different fields, and we're very proud of our alumni. So for example, just on this page, we've highlighted 3 alumni who've made a name for themselves in completely different areas, in petrochemicals, in pharmaceuticals, and even becoming ministers of state. So with that, I'd just like to end by saying that we are very proud of our alumni. We have an alumni family that stretches back well into 5 decades. And our alumni have become, have gotten employment in so many different areas, both locally and globally. It's a real pleasure to be part of such a big family. And we maintain very strong contacts with this extended family of alumni. So when you join us, you're immediately inducted into this very large family, and we welcome you to join us. So in the end, what I'd like to emphasize is that at NUS Chemical Engineering, we are very passionate about teaching. We have disciplinary strength in both the core and frontier areas, the future of chemical engineering. We constantly try to innovate and bring new teaching methods to the fore. We're very proud of our alumni network and the industry connections that arise out of such a big network. And chemical engineering just opens you up to so many diverse employment opportunities. If you're interested to know more about chemical engineering, you can scan the QR code at the top of this slide. And if you want to know more about other programs, please feel free to scan the QR code at the bottom. Thank you very much, and I hope to see you at the open house.